Imagine you're floating down a river. Maybe the stream is calm and serene, flowing without obstruction. Or perhaps it's a rushing river, churning and splashing over rocks. Well, the way water moves in a river is a lot like how electricity flows through a wire. But when we say that electricity is flowing, we're really talking about the flow of electrons. Electric current is the total amount of charge passing through a wire over a period of time. But how does current actually form? What can it pass through? And what determines how strong it is? It's time to sit back, relax, and go with the flow.
Hello everybody, my name is Faris and we are going to discuss electric current and Ohm's law. First, have you ever thought before what's electricity and how our life will be without it? How this electricity run devices in our home, and these devices are connected together, but if one device is broken, it doesn't affect the other devices. Okay, anybody here know what's electric current? To know electric current, I want you all to close your eyes and imagine with me yourself sailing in a boat in a river, and there are many waves against you, resisting you. Okay, now you can open your eyes. The electric current consists of many small particles called charges. These charges in the wire like the boat in the river, and the waves against you or resisting you is called resistors, but in wire condition. And from our imagination or our experiment, we can define electric current as the flow of the charges in a conducting material. Now you remember the boat we imagined. I think this boat needs a wind to blow it and do some work on it because of its movement. Okay, and our current needs some work too. This work called electromagnetic force. Electromagnetic force, or EMF, is the work done to transfer electric current through the terminals of the wire. And anybody here can define the resistance from what we said? Okay, resistance is the opposition of the flow of the electric current. Now we got to talk about connection in electricity. In electricity we have two ways of connection: series connection and parallel connection. In series connection, resistors are connected together to get a higher resistance, but in parallel connection, resistors are connected together to get a lower connection. In series connection, the voltage of any resistor are different from the others, but in parallel connection, all resistors have the same voltage. In series connection, if one lamp is damaged, it affects the another lamp. The another lamp will stop lighting. The circuit is opened. But in parallel connection, if one lamp is damaged, it doesn't affect the another lamp. The another lamp will still lightening. Okay, let's see it on the real life. Here there are series connection circuit and parallel connection circuit. If we disconnect one lamp in series connection, the another lamp will stop lighting. Let's see it. The another lamp stop lighting. But in parallel connection, if we disconnect the another lamp, the lamp will still lighting. Let's see it. One lamp is damaged or disconnected, but the another lamp still lighting. Bicycle. Finally, your homework is to define the electric current and mention the advantages and uses of series connection, and mention the advantages and uses of parallel connection, and solve page 24 and 25 in student book.